Welcome back to Wes Explains Best. Today we are starting section 11.3, surface area of pyramids and cones. If you don't think pyramids and cones are relevant, then you haven't eaten ice cream and you've never heard of a place called Egypt. Moving on. So a regular pyramid, this is what we need to talk about. When it's talking about regular, it's talking about the base being a regular shape. So the base equals regular. Now what that means, if you don't remember, is all sides are equal. Oh, we'll just put congruent for a shorthand, okay? All right, so parts of a pyramid. We have the vertex up on top. That's the top of the pyramid. Let me look for the corresponding color. So this is the vertex, okay? This is the base edge right here. This is a base edge, okay? Then we have the base. The base is the entire area, okay? When it's abbreviated, it's a capital B, not a lowercase b. If you're talking about lowercase b, you're talking, for example, a triangle. This would be lowercase b for that base, and then we'd have the height. That's lowercase. This is uppercase b. Okay, another important aspect, this green side. Now, a green side would be also corresponding to some, well, I guess it's teal, or whatever color you want to call that, like neon green. This is a face. So this whole part of a pyramid, the part you could slide down with a carpet or something like that, that's a face. So let's write that down. Now it's a lateral face. We'll call that a lateral face. Okay? If that's a lateral face, then this is a lateral edge. This is a lateral edge. And then finally we have the height of the pyramid. This is what would tell us how much altitude it would be. If we measured, like, for example, Pyramid of Giza from the base, where it touches the ground, all the way to the top, that would be the height. A perpendicular line from the vertex to the base. Okay, so just a little bit more information. There's lots on a pyramid to consider. This is the slant height. How is this different from the height? Well, it's different from the height because the height goes into the middle of the pyramid, where the slant height does not. Okay, so that's inside the pyramid. Slant height would be this direct line down, sliding like on a sled from the vertex. Like, imagine yourself, you're up here. Let me draw them out. You're up here, and you're sliding down a little sled down the side of the face. Okay, and this needs to be a 90-degree angle. That's important. So that's the slant height. How is this different from a lateral edge? A lateral edge would be along this little bump. You wouldn't want to sled down this. Okay, so that would be a lateral edge. Let's just call that a lat edge. Okay, slant height would be flat because it's going down the middle. Lateral edge is where two lateral faces come together. Now, we just have, this is a hexagonal pyramid to show you that this is a regular shape. So it could be any shape. And a pyramid could be have as many sides as you want. It just affects how many lateral faces there are, and it affects the area of the base, etc. Okay, so that's something to keep in mind. The most common ones you see the most often are square, rectangular, or triangular. Okay. Now, if you were to flatten out a pyramid, you would get this. This is the net. So this would be the net. A net is like a flattened out 2D version of the pyramid so that you could build it. So if you were to get an Amazon package and it gave you a cardboard box, you could assemble it by folding these flaps up like this, and that would form your pyramid. Okay? To give you an idea how you would figure out the surface area, let's first talk about the lateral area. We would need to calculate the area of these four triangles. Now, what's the area of a triangle? The area equals 1/2 the base times the height. Well, the base, we'd have to do this times 4, unless we consider that we can take the base of the triangle. Let me show you the base real quick. The base of the triangle, and multiply that by 4, and we take care of that, and then we can just multiply it by the height. Well, what's this area or this distance I just labeled called? That is called the perimeter. So we can find the lateral area by taking lateral area equals 1/2 the perimeter times the height. Now, when I say height, what I really mean is I mean this slant height. The height from the middle up would not be this distance here. Now, if we're folding this up, the side of the triangle up, this would be the slant height. That would be the height of that triangle. You fold it flat, and that height is that right there. It's not the height that goes into the middle. That's a very important distinction there. So really what I need to write here is I need to write what the slant height, perimeter of the base times the slant height. Okay, and slant height is usually distinguished with this little L. Okay, so this is your formula for lateral area. Okay, now surface area is pretty intuitive after this. It's almost the same as what we did with the prisms. So surface area equals the lateral area. And we used to have two bases with perimeter. With pyramids, we only have one base. So this is plus the base. I almost wrote 1b, but you don't need to write the 1. You can just say plus the base. Remember, big B means the area of the base. So if we were going to write this all out, it would be surface area equals 1/2 the perimeter of the base times the slant height plus the area of the base. And I can just do that, or I can write, or I could write just big B. But I kind of like this better. We'll go with this. And the reason why I don't have a specific designation for the area of the base is because it could be a triangle, it could be a rectangle, it could be a hexagon. So there's all different types of bases. So it's a case by case what you're going to use. Let's go ahead and get into an example, and then we'll move on to cones in the next video. So here's our example. Find the surface area of the pyramid. We're given the slant height. No, sorry. We're given the height. I should have asked you guys what we got. This is the height. So the reason why it's a height and not a slant height is because it goes from the vertex to the middle of the base. And then we're given that this is a square pyramid. So this is a regular pyramid because that's 30 and 30. So we have some things, but we need a little bit more. And let's figure out what we need. For our formula for lateral area, what we need is the perimeter of the base, and we need the slant height before we can proceed. So let's get our formula ready. 1/2 the perimeter of the base times the slant height. Perimeter of the base is pretty easy. What we're going to do is we're going to say 30 plus 30 plus 30 plus 30, and that equals 120 meters. Slant height, what is it? A lot of people would mistake 36.4 as the slant height, but that is not true. What we need to do here is we need to draw in our slant height. So that is our slant height. We don't know what that is. We would need to find it. How do you find the slant height? Well, in order to find the slant height, we need to draw a triangle. So let's draw a triangle. There's our slant height. There's our actual height. Okay, and as we know, the actual height is perpendicular to our base, and this is our base. I know it doesn't look perpendicular, but I think you guys get the point. And that's perpendicular. Now, we know the height is 36.4. We are looking for the slant height. In order to use Pythagorean theorem to find the third side, we need a second side. Well, how can we figure that out? Well, if this is the center of the base, then we know that this distance here should be halfway from both sides. So if it's halfway, then this distance right here is 15 meters because the whole distance is 30. So this is 15. Now we're ready to use Pythagorean theorem to find our missing slant height. Let's go ahead and start. So we have 36.4, and we need to square that, plus 15 squared, and that's going to be equal to L squared. This is where a calculator comes in handy. 36.4 squared plus 15 squared, I believe, is 225. 15 squared. Okay, and I got 1,549.96 is equal to L squared. Now I need to take the square root of it to get L by itself, and I get 39.37 meters. 39.37 meters, so almost 40. If you wanted to, I guess you could round to 40, make it easier, but no, let's be specific here. Let's be mathematical. Let's be mathematicians. 39.37. Now we're ready to apply our formula. Lateral area equals 120 times 39.37 times 1/2. I already have it stored on my calculator, so I'm going to do 39.37 times 120, and then I'm going to divide that by 2 or multiply by 1/2, and I get that my surface area is equal to 2,362.17 meters squared. And that is my lateral area. We're still not done, if you can believe it. If we're trying to find the surface area, it's just one more quick step. The lateral area is the tough part. So we're going to do surface area equals the lateral area plus the area of the base. So we just need to do 2,362.17 plus the area of the base is going to be, area of the base equals 30 times 30, 900, plus 900 there. Sorry about that. So we're just going to add 900 to our answer that's already on our calculator, and we get 3,262.17 meters squared. There we go. There's our answer. Now, in the next video, we're going to talk about cones. I hope you found this helpful, and I'll see you next time on Wes Explains Best.